Morning, everybody. I'm going to show you how to do the phet simulator for the electric potential lines activity. This I want to be done after we've learned about the concept of electric potential, which we did for the simple case of a uniform field between parallel plates, before we go into the more general way of quantifying electric potential, namely for spherical sources or point sources. So what I want you to explore here is how we represent equipotential lines. They're analogous to electric field lines. Electric field lines convey force anywhere in a field. Electric potential lines or equipotential lines convey the electric potential. Essentially, not quite your potential energy, but the analog to that, the energy per unit charge. And then at the end, we want to establish a very important relationship between electric potential and electric field intensity, those lines. So you're not gonna make maps of these so much, but you're gonna view them and try to understand them, and then I'll do a little tutorial to kind of sum up the key points from this. So the instructions on the sheet are fairly clear, but I think something's changed about this website where I want to clarify a few of the measuring tools. So that's the motivation for this. So generally what you're going to do is you're going to take a charge, it could be a positive or negative, and place it in the field. Okay. Now I could map out what the electric field likes in terms of a series of arrows, but that's really not our main goal. We'll do that a little bit. I'm interested in equipotential. So the key tool is right here. All right, where I can move this anywhere. I can see what the value of the equipotential is. And if I stop somewhere, I want to put a line that shows where 5.951 volts are everywhere in this field. I just click the pencil. Okay, and so I've got that. And if I want to see the value, I can click values. And I'm going to ask you to do a series of equipotential lines for different situations. And again, just do the potential. If you want, unfortunately, you can't erase individual ones, at least not that I know of. If I press the eraser, it will get rid of them all. So just a word of the warning. The second aspect that I want you to do is for part of it where you're going to take some data and make a graph, you're going to need to use the tape measure. So if I want to know a distance, let's say from the charge to a particular equipotential line, I just line up these two cursors. Okay, that's where so if I want to measure from the positive to the second line, I don't have to be exact. I don't have to worry about this little positive being exactly over the charge. There's a little wiggle room there, but that's how you use that. Okay, so I can put this stuff back. I've got values. If I want a grid to help me to align things, you have that. And then electric field, like I said, I can do this where it gives you the direction and the magnitude is indicated by the brightness. If I want direction only, I can ignore. You just click that button. And voltage, that just gives you a pictorial of the intensity, but the lines do that as well. Lastly, sensors. So if I want to actually know the strength of the electric field intensity, not the electric potential, I can use a sensor here and place it anywhere in the field, and it'll give me a magnitude and direction specifically. Okay, so I think that pretty much summarizes what we want to do. So you're going to look at this for a single charge. You can then look for a negative charge, and as soon as I bring that in, it erases everything, and then I can start making my equipotential lines again, and then looking at the field relative to those equipotential lines. All right, good luck with the exercise. Hopefully it's fairly self-explanatory. I know I'm going to ask some questions you might not be exactly sure conceptually, but give it your best shot. Okay, I want you to understand this idea of electric potential or voltage, because it's actually very, very important in the grand scheme of things. I know you're used to voltage in terms of a circuit. This is the most general way of looking at it.